Now in this example, we have been given a circuit in which we are required to calculate the power delivered by the current source. Okay, this current source. So we know that power is equals to V into I. So we need to calculate the voltage and current. But current we already know because it is a current source. But we don't know the voltage across this current source. So we are required to calculate the voltage across this current source to get the power delivered. Now for voltage, let us do a nodal analysis at this node. Let us say the voltage at this node is V. And let us ground this node. Okay. So the voltage at this point will be 0 because we have grounded. Now the voltage at this point will be 0. Now the voltage on the other side of this voltage source will be 1 volt because here the voltage was 0 and there is an increase of 1 volt, that is minus to plus, there is a rise. So here 0 plus 1, that is 1 volt. The voltage at this node is 1 volt. Similarly, the voltage on the other side of this voltage source will be, at this point is 1 volt. Now there is a decrease, that is plus to minus, there is a decrease of 1 volt. So 1 minus 1 will be 0. So the voltage on this side will be 0 volt. Okay. Now let us assume the current direction like this, that is away from this node. Now let us apply the KVL at this node. Incoming current is equals to outgoing current. There is a one incoming current, that is 2 ampere. Incoming is equals to 2 is equals to, now the current in this branch will be, that is in this direction, that is V minus 1 upon 1. Okay, V minus 1 upon 1, that is outgoing current. Similarly, the current in this branch will be V minus 0 upon 1 plus V minus 0 upon 1. That is sum of incoming is equals to sum of outgoing. Now let us simplify this. 2 is equals to V plus V, 2V minus 1. Now from here you will get 2V is equals to 3. If you simplify this, V will come out to be 3 by 2, that is 1.5 volt. Okay. So the voltage at this point is 1.5 volt and the voltage at this point is 0. So the voltage across this current source will be 1.5 minus 0, that is 1.5 volt. Okay. And this will be positive because this terminal is at higher, and this will be negative because this terminal is at lower potential and this is at higher. Now we can easily calculate the power, that is V into I. Value of V is 1.5 and value of current is 2. That is 1.5 into 2 is equals to 3 watt. Now we are required to find out whether this power is delivered or absorbed. Now there is a thumb rule to decide. If the current come out from the positive terminal, then the power is delivered. Here you can see that 2 ampere current is going out from the positive terminal. So that is why this is a power is delivered. If suppose the case was opposite, that the current was entering into the positive terminal, then the power will be absorbed. Okay. So the answer is 3 watt, that is delivered.